Section R7 is on applications of equations. We're going to look at several different real-world word problems. So here's problem-solving strategy, and you can pause this and read through if you'd like. We're just going to go ahead with our examples. First is the simple interest formula. I equals PRT. I stands for interest, P is for the principal or the initial amount invested or borrowed, R is our rate as a decimal, and T is time in years. So example 1 says Kent invested a total of $8,000. He invested part of the money for 2 years in a stock fund that earned the equivalent of 6.5% simple interest. He put the remaining money in an 18-month certificate of deposit, we call that a CD, that earned 2.5% simple interest. If the total interest from both investments was $855, determine the amount invested in each account. So the first thing we're going to do is define a variable for the amount invested in one of the accounts. So we're going to let X be the principal invested in the stock fund. Okay? So if X is the amount in the stock fund, then we put $8,000. Well, we put $8,000 total, so that means 8,000 minus X will be the amount that's left for the CD. Okay? So we need to find the interest for each case. So the interest for the stock fund, I equals PRT, will be the principal amount, which we defined as X. Then the rate for the stock fund was 6.5%, so that's 0.065. And the stock fund was for 2 years. And this reduces to 0.13x. Then we need to find the interest in the CD. The principal amount for the CD was 8,000 minus X. The rate was 2.5%, so that's 0.025. And the time was 18 months. That needs to be in years, so that's a year and a half or 1.5 years. Reducing this gives us 0.0375 times 8,000 minus X, and distribute so that we have 300 minus 0.0375x. So to find the amount invested, we need to take the interest from the stock fund and add that to the interest from the CD. And that'll give us the total interest accumulated, which was $855. We'll put that down in a second. Okay, so the interest from the stock fund we found was 0.013x, and from the CD add those together, and that'll give us 855. And so we go through here now and solve for x. Add our like terms, so we've got 0.0925x, and subtract 300 from each side. And then we divide and we'll get 6,000. So what that means is that the amount invested in the stock fund was $6,000. And now we can very easily find the amount invested in the CD. It was 8,000 minus X, which I found to be 6,000. So the amount invested in the CD was $2,000. Moving forward, we're going to look at mixtures. Example 2 says household bleach contains 6% sodium hypochlorite. How much household bleach should be combined with 70 liters of a weaker 1% hypochlorite solution to form a solution that is 2.5% hypochlorite? So again, we're going to define a variable. So we're looking for the bleach, or the 6%. So we're going to let X be the amount of the 6% solution. $70 liters is the amount of the 1% solution. And so the amount of the 6% plus the amount of the 1% will be giving us the 2.5% solution. Okay? So we're going to take the 6% solution, we're adding that to the 1% solution, and we're going to be getting a 2.5% solution. And so what we need to do is we need to multiply the percentage times the amount in our little equation here. So the percentage, 0.06, times the amount for the 6%, that was X. Then we have our 1% times the amount of the 1% solution. We were told that's 70 liters. And then 0.25%. And so the amount in the 2.5% solution was X plus 70. And then we go and we solve for X. Multiply there. Distribute. I'm going to subtract 0.2 or 0.025 from both sides and subtract 0.7 from both sides. We've already solved equations, so I don't feel like I need to show every single step here, but you can if it helps. And then we'll divide to get X is 30. So this tells us that we need 30 liters of the 6% solution, which was the household bleach. Okay? Next, we're going to look at motion. So we need to remember the equation distance equals rate times time. Trent takes his boat 6 miles downstream with a 1.5 mile per hour current. The return trip against the current takes 1 hour longer. Find the speed of the boat in still water, in absence of the current. So let's say B is the speed of the boat in still water. So what we're going to do is we're going to take the time of the trip against the current and the time of the trip with the current. And we're told that the return trip takes 1 hour longer. And so the return trip was with the current. So if we take the time against the trip to and subtract off the time with the return trip, then that should give us 1. Now, something we need to think about here, if we're looking at time, then we need to solve our D equals RT for time. So time would be D divided by R. Okay. Okay. So the time against the current, the distance was 6 miles. And we're going against the current. So we say the speed or the rate is 1 minus 1.5 because we're going against it. Going with the current, we're still 6 miles, but we add B plus 1.5 because we're going with the current. To solve this, best thing to do to get rid of the fraction is multiply by what would be your common denominator. So B minus 1.5 times B plus 1.5. If we multiply 6 over B minus 1.5 by B minus 1.5 times B plus 1.5, then the B minus 1.5's cancel out. So we're left with 6 times B plus 1.5. The B plus 1.5 cancel out in the next term, so we've got 6 times B minus 1.5, and then we're multiplying all of it 1, so we have all of B minus 1.5 times B plus 1.5 here. And so we go through and simplify. Distribute your 6 and negative 6. Notice that's a plus 9. And then full. So we've got B squared. It ends up as B squared plus 1.5B minus 1.5B. So they go away. Minus 2.25. Okay, notice the 6 B's cancel each other out. And that gives us 18. Okay, so solving for b squared, if we'll add 2.25 to both sides, then we get 20.25. To get rid of the square, we square root both sides. And so b will be plus or minus the square root of 20.25, which is 4.5. Now, let's think about this. There's two solutions, but one of them is negative. And we can't have a speed that's negative. So the only one that's going to work for us is the positive 4.5. So we've just found that the speed of the boat in still water is 4.5 miles per hour. Okay, we're halfway through here. Let's look at an example involving work. At a mail order company, Derek can process 100 orders in 4 hours. Miguel can process 100 orders in 3 hours. How long would it take them to process 100 orders if they work together? So, how long? That's time. So we're going to say T. And we're going to say time to process 100 if they work together. And we're also going to just say that 100 orders is one job. And that's going to help us here in a second. Okay, so what we need to do is we need to take Derek's speed and add it to Miguel's speed. And that's going to give us the together speed. And it says they can, Derek produces 100 orders or one job in 4 hours. 1 in 4. That's a fraction. So one job in 4 hours. Miguel's speed is one job in 3 hours. And together, they're going to do one job in how many T hours? So we've got 1/4 plus 1/3 equals 1 over T. And we need to solve for T. So let's multiply by what would be the common denominator, 12T. That gives us 3T plus 4T equals 12. So we have 7T equals 12, and T is 12 over 7, which doesn't really make sense, so we'll rewrite that as 1 and 5/7. So it takes 1 and 5/7 hours to work together and get 100 orders. Part B asks us how long would it take to process 1,400 orders if they work together. So we know that 100 orders was 12/7 hours. And so we want 14 times that, 14 orders. So multiply by 14 and we get 1,400 orders would take them 24 hours. Next, we're going to use the Pythagorean theorem. So if you'll remember, the sum of the squares of the legs is equal to the square of the hypotenuse, or a squared plus b squared equals c squared. So a window is in the shape of a rectangle with an adjacent right triangle above. The length of one leg of the right triangle is 2 feet less than the length of the hypotenuse. So if we say let the hypotenuse be x, then one of the legs is x minus 2. The length of the other leg is 1 foot less than the length of the hypotenuse, so x minus 1. It wants us to find the lengths of both sides. Okay, so a squared plus b squared, so your sides squared, add them together, equals the hypotenuse squared. Okay, solve for x. We need to take x minus 1 and square it. That's x minus 1 times x minus 1. So you're foiling, and we get this. Then we FOIL x minus 2 times x minus 2. All equals x squared. Combine like terms here. And we've got a quadratic, so we need to get it equal to 0. So subtract x squared from both sides, and we have this, which is factorable. Factors to be x minus 5 times x minus 1. Okay, and so if we set both of those equal to 0, then we get two solutions, one where x is 5 and the other where x is 1. Okay, now we need to determine, are both of these going to work for our window? Go back over here and plug in 5. Well, that would give us a hypotenuse to be 5. 5 minus 2, this side is 3. 5 minus 1, this side is 4. Good to go. But let's try 1. What if the hypotenuse is 1? 1 minus 2 is negative 1, and 1 minus 1 is 0. We can't have sides that are 0 or negative 1 or negative. So 1 is not going to work as a solution. So in this case, we know that the hypotenuse is 5 feet. The first side is x minus 2, 5 minus 2, or 3 feet. And the second side is 5 minus 1, or 4 feet. Our last example deals with vertical position of an object. So for this, you're thinking about if you shoot a rocket straight up in the air, then what is its position over time? Okay, let's read this. So S is your position. That's equal to negative 1/2 gt² plus V naught T plus S naught. G is your acceleration due to gravity. And you're going to want to write this down. The acceleration due to gravity is 9.8 meters per second squared. So you need to know that. And that'll be a case in any of your problems. V naught is your initial velocity, and S naught is the initial position, or the height for the particular problem. So in example 6, a toy rocket is shot straight upward from a launch pad of 1 meter above ground level with an initial velocity of 24 meters per second. Write a model to express the height of the rocket in meters above ground level. So our formula is this. And so we're going to plug in. Let's go over here. You see, we said G is 9.8. Our initial velocity, it said, was 24, and the initial position is 1. So we plug in. And simplify. Gives us negative 4.9. Okay, so there's our expression for the height of the rocket. Part B asks us, when is the rocket at a height of 20 meters? So when would we find T when the height, or S, is 20. Okay, so we're going to find T, subtract 20 from both sides. And I'm going to multiply everything by negative 1 to get rid of that initial negative there. Just make things easier in the long run. So we have 4.9t squared minus 24t plus 19 equals 0. To solve this, we're going to have to use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. That gives us positive 24 plus or minus the square root of 203.6 divided by 9.8. Okay, so T will be 24 plus the square root of 203.6 divided by 9.8, or T will be 24 minus the square root of 203.6 divided by 9.8. This first one gives us 3.9, and the second one gives us just 1. Now, which one or are both of these solutions true? Well, if we think about it, okay, this rocket is going up. Oh, my tablet is thinking. Okay, it's going up, and then it's coming back down. Okay, and it's hitting a height of 20 feet twice. Okay, here and here. And so both of these solutions are true. The rocket will be at a height of 20 feet at both 3.9 seconds and at 1 second. Okay? Go back over here and grab this. And the last part here asks us to find the time where the rocket is at 40 feet. Okay? So yeah, we're doing some of the same stuff here, but you're going to see that there's a reason for us to do this problem. So when we subtract 40 and then multiply by -1, I'm not going to go through all the steps, I've already done it once. We get same thing but plus 39 there equals 0. And so quadratic formula says negative b plus or minus the square root of b squared minus 4ac all over 2a. When we simplify this, we get 24 plus or minus the square root of negative 188.4 divided by 9.8. So there's a problem here. We've got a negative a square root. Well, we just did imaginary numbers, so yeah, we could use an imaginary number here. But the fact is, this is a real-world problem. We can't use imaginary solutions for a real-world problem. So the issue is the fact that this rocket does not, because of that negative in the radical, ever hit 40 feet. Okay, that's what that's telling us. So the rocket will not reach 40 feet.